Hello everyone and welcome to another video. I know it has been a very long time. Um and yeah, that's basically it. It has been a long time. I've been developing enterprise software for the past 5 years. And the thing has remained exactly the same, but now with the added factor of AI and all of that shit that computer science has turned into. So, I decided to record a video, a freeform video with like just a very broad open plan where I program the old way, like we used to in the old school, using my own hands and brain. And yeah, so I thought about what can I do in a single sitting. So just want to record some like a very simple project in a single sitting, from start to finish. And well, why not do a fourth like language, right? So fourth is a programming language, is stack oriented. It was created by the great genius Chuck Moore. Um, yeah, and super simple programming language, and yeah, that's basically it. So this is how it works. It's in reverse Polish notation. This pushes numbers into onto the stack. This executes the operation using whatever is on the stack. um yeah, and that's it. Okay, that's it. So I'll do very minimal fourth like language, my own flavor of fourth. I would like to know exactly what's the vocabulary of fourth. I thought about doing it in assembly, but I think I'm going to do it in C for now because I don't have time to like remember all of the assembly instructions from x86 64. So let's search for fourth programming language vocabulary, so we can have like a simple idea. Um, yeah, I think this one. Oh, this has a lot of stuff. So this is the entire standard, which is very extensive. So yeah, basically we are probably going to just implement this one, and this is the store. This is store something on a specific address. Um, then we can also implement, I don't know, this one, which is the uh, yeah, it loads a value. They don't call it like that, but it loads a value from a specific address. And maybe like some other very simple stuff. Let's see how it goes. So here we have like an empty project. Let's create our file. We can call it p4th, like so, .c. I called it p4th because I'm Pedro, and yeah, the p comes from my name, Pedro. Let's do something very simple at the beginning. Standard IO. I don't think I'll need command line arguments for now. We can return 0. Well, we can even be more cross-platform and include standard leave, and here we can exit with success, so it's even better. And let's just printf for now, right? So we can just say hello world. All right, something simple. So to compile this, I think I'm going to use the WSL because I don't like Windows. I'm still forced to use Windows because I'm finishing up my masters, and I require Windows for some of the software that I use. So yeah, we are inside the WSL. Let's use GCC, and we can compile it as p4th, p4th.c. We can use WAll. We can use, well, let's use the C99 standard. I think it's nice. Yeah, why not? So this should compile exactly, and we can immediately run it afterwards with p4th. All right, so it does execute. For now, I think, like, since I want to do the smallest possible project right now, and I want to finish it in a single sitting, I think I'm just going to receive stuff from the standard input. Um, So let me think. I can simply have a buffer, right? Okay, let's call it buff. I can call it buffer. And this buffer can have, I don't know. Let me try to think about it. Maybe 1024 characters is enough. Let's assume it is. So we can do something like that. It can be static. And here we basically want to read. I don't know if read is part of the. I don't know if my WSL instance has man pages. Let me check. Oh, it does. So this comes from standard IO. Okay, so this is actually not a syscall but actual function in libc. All right, so fread gets, okay, the buffer, so we can just pass the buffer. Then it needs the element size. But that's not what I want. So I want like something more like fgets, maybe. Is that what I want? So reads in at most one less than size characters from stream and stores them into the buffer pointed by S. When it stops after end of file or a new line. If a new line is read, it is stored into the buffer. Okay. And what's the behavior of fread? The behavior of fread reads n member items of data, each size. All right, so it's slightly different. So I think I want fgets actually. Is there any other function useful in the man pages for us? Let me try to see. Yeah, we only have fgets, okay. Okay. In the C also we have read, but this is a syscall because it's section 2, right? Section 2 is 6 syscalls, I think. We have this one, fget ws. I don't know what that is. We have gets, the usual gets. Yeah. Let me just try to read fget ws. Fget ws, just to see what this is, because I've never seen it. Oh, this is for white characters. Okay, I don't care about that. So let's use fgets instead, like so. And what's the signature? So it has a buffer, it has a max count. Our max count is going to be this one. And this is going to be standard in, right? Exactly. So this returns, what's the thing that we need here? Okay, so this reads, it's fine. And it returns S on success and null on error, or when end of file occurs with, well, no characters have been read. Okay, so we can do what? We can do something fancy. We can do something like this. So this is my words, right? So we basically read a word. Well, it may not be actually a word. For that we need this, yeah, I'm doing stupid stuff. For that we need str talk, if I'm not mistaken. Yeah, this comes from string.age. So let's include string.age. Right, and just to be clear for the video, so you guys don't like get lost. What I'm doing here is that I'm going to like receive from standard input everything that I press until like the new line, and then that's going to be stored as a C string inside this buffer, and I can printf it for you just to I don't know, something like this, and I can say something like this, and here I can place the buffer like that, and I can execute it. Yeah. So if I do something like I don't know, loop, this basically reads the entire thing. And if I do other stuff like loop swap 42, something like that, it basically prints everything. So what I need now is to break down this entire buffer into tokens, right? Because Forth is a language that is broken into words, into tokens, and they are, it's very simple, very minimal, because every word is like separated by white space, so we don't get any issue with that. All right, so how does str talk work? So we already included string.age here. We need to get that. All right, so str talk, it needs the buffer, right? And here for the delimiter, it accepts a string. So I suppose any character inside that string is going to be used as a delimiter. May specify different strings. So let me, I can test it. I can test it. So if I do something like a space, well, let's say ASCII all white. White. I cannot type spaces. What are all of the white spaces in ASCII? Yeah, but I want, okay, so we have tab, we have the space, we have the new line. So that's a space, that's a tab, that's a new line. We have vertical tab and all of this stuff. Sure, I don't know what this is, but we have /f/r for carriage return. Yeah, and I think that's basically it. This is basically, but this is okay. This is supplement. All right, but this is Unicode. This is not ASCII. I asks for ASCII. Okay. We have null. I don't think we care about that. Yeah, I think it's fine. Vertical tab. Yeah, I'm gonna stick with them. So, this is also part of POSIX, I think. So, because there was an issue with the str talk somewhat that forced it to create this version. I don't remember exactly what it was, but or more non-empty tokens on the first call str talk, the string to be parsed should be specified in str. In each subsequent call that should parse the same string must be null. Okay, that's interesting. So maybe the version function related version, the save ptr argument is a pointer to this use that is used internally by the context between successive calls that parse the same string. On the first call str talk r, str should point to the string to be parsed and the value is ignored. In subsequent calls str should be null. Okay, but the behavior is the same. And say should, okay. This str talk all right, so let's use str talk r, right? But this is only on the standard 2008. Well, anyways, this one, yeah. Okay. And this should return me the first word, right? It's going to be this word, that. And you're telling me that when I have a loop, I need to pass this as null. Now, what I want to know is if this like allocates memory. Alloc, malloc. It doesn't say anything. Okay, so the behavior is actually interesting. So the limiter is by character, so it's not, the delimiter is not the entire string. It's like any character inside a string can be a delimiter, which is cool. But now I want to know exactly what it must allocate memory, right? It must allocate memory. So let's see the example here. Why is it? Oh, they don't have it. Okay. We have str1, we have that, and we have save pointer that, and if token is null, we break, sure. But they never free the memory. That's what's very strange. That's very strange. Let's search on Google. Does strtalk allocate memory? It modifies the... Oh, it modifies original screen by replacing... Okay, so that's what they were... Well... Yeah, but it can modify it because I'm not going to use it, am I? And what about this one? Yeah, I think it's fine. I think it's fine because it's going to like insert the like the null termination character when I don't need any of the content, right? Because it's going to be like a space or any of these white spaces. So I think it's fine. Now for str talk, let's just use str talk for now and forget about the R version. And let's see what this prints. So if I do this and say something like that, and here I put the words, right? That's not what I wanted. Yeah, this is what I want. And I say something like dupe swap. I should only get dupe. Okay, that's basically the behavior I want. And so then, I read the buffer, right? And then I need to break down this buffer into words. So what can I do? I can do something like, yeah, I can do a for loop, right? I get that. So this is going to give me the words, and if the words is not something that exists, I can break, right? And for now, I can just print the word like so. Yeah, so let's test it. If I say dupe swap 42, oh, it's, yeah, okay, I forgot. Yeah, exactly, I forgot the stuff. So once, yeah. So let's do the following. Let's do it like this. While word is something, right? And I don't need this anymore. And here I just need to do that at the bottom, but here I need to provide null, right? Exactly. So if I do this stuff again, and I say dupe swap 42, I get the individual words that it was on the buffer. Okay, that's pretty cool. That's pretty cool. But now, as you can see, like once I write dupe swap, it parses both of the words, but like the prompt or the REPL terminates, right? So we need to wrap all of this into something, right? So let me think, what can I do? I can say a while. Well, let's do for, right? Something like this. Something like this. And that's basically our loop. So before the f gets, we can say f puts or something, just to be simple. And we can just print. I don't know what's the default prompt in Forth. I don't know if they have anything specific. Forth prompt defaults. Do they have anything? Forth REPL default prompts. I don't know about it. Does this standard have anything? Yeah, it doesn't. If I search for fourth REPL and I open one of anything, what's generally the content? Well, this is like a file, but I want this is a compiler. This is a REPL. Okay, so they don't really say anything. I don't really like it. I would like at least to have something to indicate that we are waiting for an input. What can it be? Well, I can just say be fourth for now, right? Something like this. Yeah, like this. And this is going to be standard out. Yeah. So if I do it again, okay, so we have p fourth. Yeah, if I do the swap, I parse the words, and it prompts me again to add stuff to it. Cool. So I did 42, 34. Yeah, it still works. Cool. And I can terminate. Here I could do something like if mem compare, and if I compare my buffer with the words quit or something. Oh, let me say, instead of mem compare, strcmp instead. strcmp. The first string is going to be buffer, the second string is going to be quit. I can just say break if that's the case. So if I am here and I type quit, it's going to quit the REPL. Okay, let me just do something like that, just to be a little bit more clear. Yeah, okay. If I do quit, it works. Okay. So here the only thing missing is basically like doing stuff with the words, right? We just need to do stuff to the words. So we'll need more variables in this case. In this, I can do something like static. Let's include. What do I actually want to include? Do I want? Yeah, it can be a 64-bit fourth. I think it's nice. So let's do std int, and here we can do an int 64t. This can be the data, right? Because we will need two stacks, so this can be the data stack. Fine, data capacity, and you can also place it like 2034. And here we will need the data count is going to be 0. Then we will need a return stack, but I'll add it when we actually need it. One thing that could be useful to us, well, is it useful? Well, we can add it. So I'm thinking about adding helper functions. We can add helper functions. We can say static inline is number, right? And this is basically just going to receive a const char some string. Can say like is digits. Yeah. And in here we are just going to use the C-type header and basically traverse the string. Here, instead of doing that, I can just do str I is not equal to the termination character, and I can just keep incrementing. So this may be an unsafe code, but it's fine for now. And the only thing we need to do is if str I is not a digit like this, we can return. So this needs to also use standard boolean like so, and here we can return a bool. Here we can return false. Otherwise, we can return true. Okay. So if our word is all digits, so if the word is all digits, we can simply convert it into a number, all right, and push that number onto the stack. So let's do it. Here we can just return it in 64, and you can say to number or to 64, I guess. We can receive this as well. And here we already know that this is all digits, so we can do something similar. We can simply have that results, and we can zero initialize it. Here we can say result is equal to the previous result times 10 plus the current ASCII character minus the value of the character 0. Right, and this is basically the operation one, so I'm going to add parentheses just to be more explicit. So we are moving whatever the result is like to the left, like one magnitude upwards, and then we are just putting the units number by doing this operation, and then we can return the result. Cool. So here I can add a function, something like void push, I think, yeah, push, something like this, push, and here we are going to receive in 64. Yeah, we get a number. Here doesn't return anything. We just need to say, okay, my data at data count is now going to have n, and my data count needs to increase. So this is the entire function. So here we just do push whatever the word is as a number. Cool. So the numbers are handled, right? Then we need to handle more things. What do I want to handle right now? Maybe it's going to be useful to handle I don't know, arithmetic operations, for example. So if, and here I can do string str copy, if the current actually the current word is equal to plus, the operation is actually quite simple. So let's do this, and this can be an else if. We just need to pop the data. So to pop the data, we can have a function. We can call it pop, right? Then we can have return whatever is like that. So we first decrement data count, right? And then, yeah, we do that. Do I want? Yeah, I guess I can do some checking. I can say if data count is equal to 0, right? So there is nothing on the stack currently. I can simply just say f puts error empty, or tries to pop an empty data stack. Right. I think that's a good one. Standard out. And here we can just exit with exit failure. Okay. And we can do the same for push. We can say if the current data count is equal or greater or equal to the data capacity, you can say try to push a full data stack, right? Something like this. So yeah, so in here we can simply just say we have an A that is popped, we have a B that is also popped, and we can just push. So let's say our stack has the following. So if my stack has an A and a B, right, and I want this operation, what's the order? Let me just double check what's the order that fourth does it. So if I push 0 and I push 5, okay, but that's, if I push 1 and I push -2, the plus is not a really good one, because yeah, it's associative or whatever. Let me try the minus. Where is the minus? Oh, it's here. So I push -1, I push 2, and I get -3. So -1, -2, yeah, 2 minus -1. So yeah, it's basically the minus easy here, right? So that's what I wanted to say, to check. So yeah, so I pop the last one. Yeah, so if I have A and B, this, I push A, I push B. This one is going to be B, this one is going to be A, I believe, right? And then I just have to push B plus A. Right, so I think that's the way to go. Cool. Let's do the minus as well, just to confirm that we did this correctly. Like so. So now if I go to my REPL and I say something like, oh, but I don't have negative numbers. Well, it's the same. So if I say 1, 2, minus, oh, yeah. We also, but it did fail somehow. If I push 1, why is it behaving like that? What's going on? Let me comment these two. Yeah, something very strange is going on. Let me try to check what's happening. So it's entering, I say prints hello. This is like the usual debug, the sloppy debug. So if I say that, okay, it's not printing there. Is it printing here? Also no. There's something very strange. So if I do this, I pass the word there, what's happening? So what? Let Let me try something else. Yeah, it's not printing there as well. Okay, so why is it? Oh, yeah, strcmp. So string compare returns 0 if s1. Okay, so here I'm doing this in the wrong way. Right, so I need to check if this is 0. Yeah. So let me just add this here. So they were never equal, then yeah, it makes sense, total sense. This is not what I want. So if I do that, okay, I pushed 1 onto the stack. And like at the end of this, I could just print the entire stack, right? I think it would be useful just for me to know exactly what's going on. So I can have a function static in1 prints, and this is void. And here I'm literally just going to loop through all the elements in the stack, in the data stack, right? And I'm just literally just going to printf them. So this is int 64t, so I can just print it as a LLD, something like this. And I can just say data I. And how is it? Okay, so this is generally how do they generally print the number? Like, what's the format? They say okay instead of okay, so they just print them, right, without any special thing. So what I'm going to do here, I'm just going to say I'm just going to say like 2 spaces, right, something like this. Then if I is less than data count minus 1, I'm going to print f a single space, and I'm then going to at the end print a new line. So this should be okay. Let me finish this. Oh yeah, for that I would need I don't remember. It's like standard, some weird standards. Let me check if okay. 64. Yeah, I don't know if this lib also includes the format specifier. It would be cool if it did, but it probably doesn't. Yeah, it doesn't. Okay, so let's just do that for now and try again. So yeah, I need to call. Oh, I cannot quit. Why can't I quit? What? That's very strange. So what's the value of this when I type quit? What? So limit buffer. Oh, because it has a new line. Yeah, okay. So yeah, I understand. So let's do the following. There is a strcmpn or something. There is some function. Oh, strncmp. Okay, so we need to use that one. So we can say str n cmp, and this accepts the first string, the second string, and then the size. And we can say size of quits, right? And this should be actually more functional. So if I try to do quit, okay, still doesn't work. Why? So let me read the documentation. Oh, because this is size of -1. I know, yeah, because this is also including the. So I want actually that. Yeah, I could do strlen, but that's going to compute the value all the time. I don't want that, so I'm going to use size of. So if I quit, yeah, this is not working. So basically what was happening here is that size of also gives you the no termination character. So it's going to give you +1 character. So it was actually like testing it against this, right? And I don't want that. So I chopped off that particular character. All right, so I still need to print this at the end. I can say print. So if I say 1, okay, I have one number. If I have 2, I have 1, 2. If I subtract, I have 1. So this is, oh, this is actually swapped. This is doing 1 -2. It should give me, yeah, I knew I was going to swap these two. So if I have 0 and a 5, I should get, so if I have this, and I do this, yeah, it's swapped. Okay, so let's quit. So I don't even need that, right? I can just do pop minus pop. Is that what I need to do? Or am I misunderstanding this? Let's try this. So if I have a 0, I have 5, and I have a minus. Yeah, so I need that, but the other way around. Okay. I should also test it against exit, but it's fine. So I need to bring back all of these. And I just need to do this. Well, actually, I actually need to do this A and B, right? And here the same, just to be consistent, even though this does not make any difference. So if I have now 0, 5, minus, I have -5, which is correct by the standard. Okay, okay. That's pretty cool. So we now have like simple arithmetic operations. We can even split. We can even add more stuff, but I don't know what value that would actually bring. We can do a macro. Yeah, we can do a macro. And say the following. Define arithmetic or something. Or I can say like this is in op, right? A binary operation. I can provide the string. I can provide the op, and I can simply well, do I need a string? I'm thinking about it. Yeah, I don't need a string. I don't want to use a string. I was thinking about if I included this in the macro or not, but I don't want to. Yeah, I don't like it. So I'm just going to keep it like this. And we can say something like this, do while. Or even I could do it in a single line, right? It's not that long, so I just need to do that, and then here, instead of plus, I just do whatever is in the op, right? And so here I can just compact this a little bit further by just saying this is a plus. Don't you like it? Maybe it doesn't like this one. Yeah, so I cannot use that. Okay. And here I can do that. And if I don't add a semicolon here, I can add it there. Cool. So let's add whatever is remaining, at least from the main ones, like multiplication and division. But I think division is also this. Divide n1 by n2. Yeah, so 7, 3. Oh, but this is interesting. Single cell quotient n and 3 and oh, but an ambiguous condition exists if n2 is 0, if n1 and n2 differ in sign. Oh, but this one is slightly different. Okay. Huh. So what's 7 divided by 3 gives me 7. What? I don't understand this commentation. Are they talking? Oh, okay, because okay, they are using this word. Yeah, maybe the macro is not that good for the idea. If I say 10 to, yeah, n1 divided by that, yeah, it's correct. But yeah, I don't want to use this macro because yeah, some operations may actually have specific behaviors, so let's not use it. The code is going to be a little bit more verbose, but it's fine. It's fine. All right. So we have arithmetic operations, we have numbers. I think that for now, the last thing I want to implement to have like more or less a reasonable fourth or very minimal fourth is the functions, right? The definitions. So we need this word, and this parse name delimited by a space creates a definition for a name called a colon definition. Okay, so this is a colon definition. It enters compilation state and starts the current definition, producing colon sys. Append the initiation semantics given below, whatever. The execution semantics of name will be determined by the words compiled into the body of the definition. All right. I'm thinking if I want to add bytecode right now, or if I just want to go the lazy way. I think I'm going to go the lazy way and do a bunch of string duplication. Or, well, let's say the following. So let's say the following. So this is, what do they call it here? A colon definition. So we can create a structure. Let's say this is a definition. This is going to contain some name, right? So this is going to contain a name, and here I'm just going to literally just hardcode the maximum size the definition can have. So I cannot definition name capacity. So I'm not even using malloc or anything, right? It's fine. It's fine. It's just a pet project. So this is my name capacity. What else? I will need a body of the definition, right? I'll need a body. And for the body, I think I'm also going to hardcode this, so I can have char, a body, and this is basically going to be an array of So let's say definition. God damn, I cannot type. Body capacity. How many words can a definition, like the words are generally quite small, right? So let's say my word can have up to 32, my definition can have up to 32 words, right? So something like this. And here I need the name, right? Like that. So these are very long. Let's say def, name capacity, let's call this cap, and here cap, and same here, cap, cap. All right. And so I'm just going to have like a global array. Yeah, I can have like def cap as well at the beginning, something like this. And this can basically be the amount of definitions I can currently hold. And here, there was one way to do this in line. I think I static definitions, and I could do something like this, right? I don't remember what was the syntax, to be honest. Or was it? Ah, it was the other way around, I think. It was the other way around. Yeah. So this basically, we have like a global array of definitions. I can call it defs, right? Definitions that have a maximum capacity for each name. They have a maximum capacity for the body. Here I'm also going to need, by the way, size t body count. This is quite a funny field. Yeah, and here I'm going to need defs count, right? And this is going to be 0 as well. Here I can 0 initialize it and make sure everything is properly done. All right, so here I can say buffer cap. Okay. So if, oh, and I'll actually need another variable, let's say bool, and what do they call it here? Compilation state. Compilation, I can call it mode, and this is generally false, right? So when I encounter a double column, so let's copy that. When I encounter this, I must enter into compilation mode, right? I must enter into compilation mode. Then when I encounter this one, I must exit the compilation mode. So I must say false, right? Exactly. But here this is different. It's different because so let me move this upwards. So I have that, and I have that, right? Exactly. So if we are in the compilation mode, or actually if we are not in the compilation mode, we do exactly what we were doing before, right? We do whatever we were doing before. If we are well, but that's interesting. That's interesting. So we will need two flags, one if the name has already been collected, and one, well, do we actually need two flags? We don't need, because we can check if the current name is empty of the current definition. Yeah, that's fine. So if we are not in the compilation mode, we can basically say if the current defs, if defs count, so this is the current one, we can actually check if defs count is equal to 0, or the current definition as an empty stuff. Why is it? Okay, whatever. If this str len of this is equal to 0, we must collect the name, right? So we can have some functions. We can say static, well, we can just copy this one, and we can say push name. Yeah, why not? Fonts char, and this is the name. And here we can check the same thing. Try to push a full dictionary. I think that in force they call it this a dictionary. And here it's like we just need to do that, but we do defs counts dot name. We must copy it, right? So we must do mem cpy, but I want to like the version with the actually that is oh, but this already is sized. Okay, this is already sized, so we can do mem cpy. The destination, this is going to be the destination, the source is going to be name, and the size is simply either if we can get this into a variable and call it n strlen of name, and this is actually name size, and here we get an n, and you can check if the name size is greater than the maximum like name, then we want to cap it to that, right? To that, yeah, it's fine. We can add a null termination character at the end to that. Otherwise we can keep this, right? Yeah, but in here it would yeah, I can yeah, I think it's fine, because here then I can do the following. If n is greater or equal to that, then I need to truncate the string, right? So I can just say this at this position is equal to this, right? This should be working. What is it? Oh, because this is a const. Yeah, this cannot be a const. I don't know why I made all of these a constant. I was, yeah, weird. So this is going to push a name, and that's exactly what I want. Oh, and at the end, no, I'm going to, yeah, I'm not going to increment the defs count right away. Let me finish this, because I only want to increment it when it actually ends the definition. So we can push the current word, push the current word as a name. Otherwise, okay, so if we already have a name in the current definition, we just want to push to the body, right? we just want to push to the body. So it's going to be similar. We can just say push body, and this is going to be some word, right? And here we must assume that the def counts is greater, well, we don't need to check anything, right? We don't need to check anything here. So this is going to be very similar. We can just swap this by words, right? We just add that, and here, but here we just need to do the following. We just need to push it into dot body at here. So I can extract, well, I cannot extract the definition because I don't have a type for it. So I need to copy all of this. Scheiße. All right. That's plus plus. So what am I doing here? I'm just basically dereferencing or passing the pointer actually for the latest active thing and also incrementing the body count. So this is going to be a definition with a very high body count, as you can see. Here I just realized that I must check if this underscore count is greater than that, right? Yeah, it's greater than that. Here, instead of doing all of this shit, I could also check if this string is greater than that, and it would simplify a lot. Yeah, let's do that. Why not? So instead of doing this, I can do strlen, and here exceeded maximum main size, right? I can do that. With that, yeah, I can say something like this. And here I need to use printf. So maximum is this, and it exceeded by that, right? So here I can do the same thing. With this, and then here I don't need any of this stuff, right? I just need that. Yeah, and I don't even need this one. So it's much simpler. I just return an error and everything is fine. Right. Yeah, I don't need any of this code. Cool. So if we are not in compilation mode, we need to push the current word to the body of the current active definition, right? Cool. And here at the bottom, we not only swap the compilation mode, but we also need to increase the current definition count, right? And now let me just check if this works without like crashing or anything. Oh, this needs to be LD. This needs to be LD. Okay, let me try to. Okay, so if I do that and I do like I don't know, square, right? Or actually 2 plus, that does 2 and then a plus and then this. Okay, it did the thing that it needed, but now I cannot call 2 plus, right? Yeah, I cannot call 2 plus, it doesn't do anything. So the thing I need to do is when I cannot find something here, I should extract this into a function because it's going to be useful, but let me extract it when it's needed. When I cannot find like the word here, like one of the built-in words, I need to search it in my definitions, right? I need to say this, defs counts, I plus, and I need to search it. Yeah, let me extract this into a function so it's easier. Let's call it, I don't know, search. It can return the index of the definition. I think it's fine if it returns the index of the definition. Okay, const char. It's basically going to search for a name. What am I typing? Okay. And why did it? Okay. So it's basically going to search the current name inside the defs I.name. So if there is a definition with that name, we can return the index. We can return the index, otherwise we return -1, like the usual thing that people do in C. So here we can get the I, we can search for that word. If that word exists, we can execute it, right? So let's say this, we can say execute, right? Is that what they call it? I don't know. We call it exec. Right. We can execute a definition by its name. Well, here we're actually going to receive the index, right? We're going to receive the index. We are going to extract the definition. Body counts, exactly. So let's call this index so it doesn't conflict with the loop variable. So we're going to loop through all of the words in the body. And here we need to execute a single word, right? So to execute a single word, we do the same thing. We just come here, body, and we get that, and this is going to be the word. Right? And now we need a function to execute this word. So let's create it. Well, yeah, we can call this exec def. Yeah, it can be exec def, and then we can have a function. It's basically exec words. Right, and here inside of this exec word, we are actually going to have all of this shit. Okay, so it's going to be like almost, well, it's actually going to be recursive. So all of this stuff, I extracted it here, but here, well, search is inside of here, but here we will need to execute a definition of this I, right? So we need to like declare these exact words above it. So we can say it like that, because inside of this we are just going to call exact word, and we just pass the current word of the body. All right, so exact def is going to call this is going to call this, and everything is fine, or it should be fine. So I can even call this exec, yeah, and yeah, I can do search def. I know that the names I'm creating are completely awful, but it is what it is. I can clean them up offline. I'm just like putting the idea down. without any like OCD. So that's basically it. So here we have two modes. We have the compilation mode where we store a definition, right? And we have like the normal execution mode where we just execute that word. And this execute word can execute like a built-in word or a more complex definition. So there are a lot of errors here. Oh yeah, because now I need to move all of these upwards. Let's do it then. We can move it here. Oh, I don't need this anymore. We can move that. Yeah, we can move it there. Okay. I'm going to clean up all of this offline, and then I can share the GitHub repo with you guys. Used but never defined. Oh yeah, because now it's called exec. Okay. Sure. All right. So it is. Let me do the following just to have a clean screen. So if I do 1, 2 plus, I have 3. Cool. If I do something like I don't know, 2 plus like I did before, and this is basically going to push 2 into the stack, then add whatever is on top of the stack plus that is 2. Okay, we now keep the 3 on the stack and we have a definition. And now, let's say I put another 3 on the stack. If I do 2 plus, this did nothing. Yeah, this did nothing. Why didn't it do anything? So I can also do the following, by the way. When I search a definition, yeah, I forgot about that. I need to do the following. Yeah, if I is less than 0, I need to print stuff onto the screen. I can say something like unknown. Well, this actually needs to be printf. Unknown words. I can just say unknown, yeah, why not? And do something like this, and I can just provide the words, and yeah, I can just say else, and yeah, do that stuff. So let me just confirm that this is being properly saved. So 2 plus, 2 plus, and then I finish it. Oh. What? That's very strange. Oh yeah, of course, yeah. Of course, yeah. Makes total sense. Because here, this stuff, so if we do this, compilation, else if, right? Else if we are in compilation mode, we do that. Well, in theory, yeah, we could in theory move this stuff like to the exec, but I'm gonna keep it there. Yeah, just to be like more explicit. So if we now do that, okay, and let's say I put a 3 and I do like 2 plus, it still complains that it does not find 2 plus. Interesting. So let me do the following. So it's trying to search. Well, the only thing I can do is to debug it, right? So printf this, here I can put that, I can put that is equal with that, and here I can just provide the name of the definition, and the result. Right, just to debug this, like so. So if I try again, so if I define it to plus, and then finish it, and then like I put a 3, I do 2 plus. Oh, it stored it as plus plus. What? Why did it store? Huh. That's very interesting. Let me do the following then. I'm gonna add a new command, a new words. I can say something like I can call it words, right? Words. And this is basically just going to print all of the available words. So it's a very nice thing for debugging. Defs count exactly, and I plus plus. And here I can just say f puts, yeah, f puts defs I dot name into standard out. Cool. Well, I need actually printf because I want a new line. So I need this, and I can add like 2 spaces here. Okay. Cool. So let me try again once more. So I do 2 plus then that. Oh yeah, I forgot. Yeah, that makes total sense. I forgot this because I do 2 plus 2 plus that. Okay, so now if I do the words, yeah, it's basically printing plus plus. That's very interesting. So let me, where do I push the name? So I push the name here. Huh. Let's say pushing this, right? Oh yeah, but here I need to move that, and at the end I need to set the termination character, right? Is that any set str copy? Yeah, I should use string copy. I think that the termination character is a bit fucked. So I should move it from there into there without this. Yeah. Well, let me just double check. So here, got, and we can say something like this, right? So, and yeah, I should do exactly the same thing. I shouldn't be doing mem copy. I should be doing string copy because since I usually use string views. I generally use string views, and so I use mem copy because I have the size of the string view. But here, since I'm using like usual C strings, I forgot I need the null termination stuff. So if I do that, but it's always pushing the name. That is also very interesting. Oh yeah, of course. So I did another bug here. I have another bug. What is it? Let me quit this. I think it's down here. Yeah. So yeah, there is a bug here. This doesn't matter this one is stupid. Yeah, because it's entering always. So if now I do the same, if I define 2 plus with 2 plus that, okay, and if I push a 3 and then I do 2 plus, it's working. Okay, so let me just remove these debugging printfs. Let me add a few more built-in words, so I can add the usual dupe, right? And this is basically going to sure, I could do like the top. Do I have, where do I have all of those functions? Yeah, here I could have something like this. Top tries to top an empty data stack, and here I can just return that without changing the data counts. So it's easier to duplicate. I can just push the top of the stack, and then we have the duplicate. Okay. Then I can do swap as well, because it's very famous. So I pop the first and the second. Man, these names I gave were awful. I need to check that. And I can just push. So I pop this one, I pop that one. I need to push A and then push B. And of course, this is not optimized at all. It can be optimized in the future. Like I understand that, and I'm aware of that. Like, don't worry. So now with dupe. Oh, yeah, forgot to change the name. This is swap. Right, this is swap. And so now I can do the following. I can define the very famous square function, right? And I can say that the square of a number is its duplication multiply, and I can finish my definition. Now, if I put like 3 square, oh, it's not working. Okay, why is it not working? Okay, if I push a 3 and I do dupe, oh, dupe is not working. Oh, I see why dupe is not working. Of course it's not working, because I did a mistake here. The top needs to be count -1. Yeah, exactly. So let's try again. If I do square, is basically dupe, multiply, and if I have like a 3 on the stack and I do square, I have a 9, right? So I can have 5 square. One really good thing about fourth is that it reads like English, right? You literally just write the words as if it was English. It's super nice. So 5 square is 25, and I can quit. So one other thing I would like to have is the drop words, and the drop is basically just a pop without anything. All right. So now, what else? Well, like, what can we do that is fancy in fourth? Like, is there any? Oh, by the way, can we have recursion? That's actually an interesting thing. So just to debug if we have recursion, let's add another one here, and let's say like a dot is going to be a print, so it's going to dump the entire stack onto the screen, right? So the dot is going to be a print. Let's define the following function. Do we have recursion working? It's a very nice function, and the only thing it's going to do, man, this name is I'm not going to use this name. Does it heck? Okay, it's a better name, so it's not that long. It's basically going to dump the entire stack, or actually it's going to push a number into the stack, it's going to print it, print the stack, and then it's going to call itself. Let's see. Okay, so we defined it. Let's put like a 0 on the stack, so just we confirm that we are appending numbers after the 0. And if I call does it rec, yeah, we do in fact have recursion. We do in fact have recursion. Okay, so we already have recursion. I was not actually aware of it. Which is very nice, very nice. Cool. So yeah, I think maybe I'm going to keep like working on this project for a few more videos. I like the way it's going. It's like super simple. We did it like 180 lines. I know that is super sloppy and everything. Well, let's clean it up a little bit. Let's clean it up. So this buffer, I can keep it. The data stack, I can keep it like this. For this stuff, okay. So let's do the following. I can do this. I can move it upwards. Let's change this symbol. Where is it? Okay. We can call it stack of data. Why are you asking me so many questions? Okay. Here, so rename, can say stack data counts. Cool. Well, do I want to actually call it like that? I think it's very explicit. When I say data in a fourth like system, I know exactly what data means. So I'm actually going to rename it back to this. And I'm going to rename it back to this. But here I'm going to say, okay, I'm going to push into the data stack. Sure. Try to push into a full data stack, so this error is more explicit. And that's fine. Here, I'm going to rename this symbol into data pop. So yeah, try to pop an empty data stack. That's fine. And here the top, it's the top of the data, and it's fine as well. Cool. So that's okay. Then we have the definitions, and maybe I want to extract this definition thingy into an actual type. So I can say like def struct. This needs to be upwards. Definition. I can call it def. Yeah, I'm going to use shorter names from now on. I can say something like this, right? Yeah. So this is the definition. It is fine. Then yeah, defs count, defs. Compilation mode is also fine, but compilation mode needs to go lower. I feel like it does not really, it's not really the responsibility of that. So of course defs is just this. Here we can say def set name. I think it's a more explicit thingy. So we can set the name of whatever is the current definition, pointed by the defs count, of course. Here we can say try to set a name in a full dictionary. So the dictionary says full, we can do anything. Here, exceed the maximum name size. That with, I can say something like this. that, and yeah, so I can say something like that. Cool. And this one is actually working right now. It's cool. Isn't there like an strn copy or something? Just so it's a little bit safer. Yeah, there is a strn copy. And it's part of the POSIX standard. So let's use it. Even though we already check here, I just want to be 100% sure. Well, but if I do that, does it null terminate? Non-null bytes from a string pointer by source into the rate pointer by dice. It's too few non-null bytes to fill the destination. Trailing null bytes. If the destination buffer limited by its size isn't large enough to hold the copy, the result variance is truncated between the two functions. Okay, so C return a value in the destination character sequence. Oh, but yeah, returns the destination. I don't know which one I want to use, to be honest. So if I have, yeah, oh yeah, big, but this 1, 2, 3, 4, 5, yeah, I don't want to use that one because it doesn't add the null termination, so I'm just not going to use it for now. Here, I can simply say def adds or def body adds or something. Add words, I don't know. Okay, yeah. Tried to add a word into I can just say that, yeah. I think it's explicit name. And here we can do the same. We can just do that, and here we can print actually the words, right? Here we can actually extract the current definition, so it's a little bit cleaner. We don't have to have all of this strain and duplication like that. Oh, but here, yeah, since we need to modify it, let's, yeah, because we need to modify this, let's do this and just swap it by arrows, and it's fine. Okay, here I can just rename the symbol to def search. So this is going to search a definition by name. We still don't care about the compilation mode at this step. We only care it like here, right? Then here is yeah, it's just exec word. Here we can call this def exec. So it's basically going to execute. What did I do? Okay. Exec. This is going to execute a single definition. We can call it def index just to be super explicit to what this is. Cool. Then all of these functions are used by this. Exactly here, I don't even need this here. I can be even lower, like so. And yeah, here I can say something like data print, right? And since this is related to the data stack, I can just move it upward. Oh yeah, I can put it there, right? So this is, the buffer can be lower. I feel like it doesn't have to be all the way up there. Well, but it's a good practice to have the definitions. Well, but I'm not following those practices, so fuck it. Yeah, I can just have it there. So this is my data stack, right? Then this is my dictionary, right? Then this is my exec. Okay, cool. Yeah, basically. Let me just add a space because my OCD is triggering me. Cool. And here I assume this is all correct. Yeah, sure. This is fine. I could clean up all of these, but I'm not worried about efficiency right now. So that's fine. Yeah, this one I could extract into a function. Why not? So I can say def exec. Here I can have the following. And have def print like so, and just have this stuff inside of it, so it's a little bit cleaner, right? Exactly. Oh yeah, I need to remove that. And then yeah, when it doesn't find anything, it just searches for it. If it cannot find anything else, it does that. Yeah, I think it's fine. Then we have the buffer. Here we have the prompt. We have that. That should be fine. Here, if we, yeah, so let me try to, that's an actually interesting. So if I try to do that, this should fail, by the way. Oh, it worked. How did it work? Oh yeah, because it's only going to be executed. Oh, I basically redefined that. I redefined, well, I didn't redefine it. Let me, yeah, so if I do this, that, yeah, well, let me say something like this, like, I know, Q, and then I do that, it still executes it. Yeah, it's very strange. So what does this do exactly? That's interesting. So when Q executes, it's going to enter compilation mode. Huh. Let me try something. So let's define a macro. Okay, let me see if we also support macros unintendedly. And the macro, my macro is basically going to enter the compilation mode, and it's going to define a word, so word one, and the word one, oh yeah, but that's not going to work because the compilation mode is outside of the exec, right? So when word one executes, well, when macro executes, it should fail, but it's not failing for some reason. I'm not really sure. But let's just say so. Word one is going to push one, is going to terminate there, and it's going to terminate there. If I see words, we have a macro there, sure, but then this is so it basically, yeah, it is ignoring that one. It shouldn't ignore that one. It shouldn't ignore that one. So why is it? So when it tries to execute macro, oh, it's this def search. That's so weird. That's actually pretty weird. So let me just print f the exec. I just want like to see the how powerful this system is. So we have this word, right? So if I do that, so let's try it again. So if I have a macro and this macro enters the compilation mode, it finds like word one, which is just pushes one onto the stack, it closes and it closes again. So now we have the macro, and if I execute this, it's going to execute that, but it skips it. Why are you not pushing? So here, let me, when I print the, when I print that, let me also do the following. Let me also do the following. So I also want to print the body. So body, it's actually body counts. Printf. I can do space and then that, and this is going to be body j, right? And only then I can actually print the new line. Okay, so let me try this just so I can actually understand what's going on. Let me clear the screen for you guys. Okay, so let me define a macro which enters in compilation mode, defines word one, it just pushes one onto the stack, it then terminates and it terminates this one. So I have, oh, I see now. Oh, this is very interesting. This is actually pretty interesting. So it basically gets what? I think I need to move that into here, right? Oh yeah, yeah. So the only thing I need to do is if that is that and I'm not currently in the compilation mode, then I need to set compilation mode. Otherwise, I know that this column definition is actually inside the body of something. It's already being compiled, right? And here I need to do the same. And I need to say by saying if I get one of these and I am, oh, but that one, yeah, that macro is not actually going to work. Yeah, that macro is actually not going to work because when I do this and basically I define this as that word one one and I close this, this is going to close. Well, it may actually work because this is going to close everything. Well, let's try it. Let's try it. If I do words, okay, so now it's properly parsed. That's good. That's good. And if I execute m, it then tries to execute this. So if I placed that, yeah. So if I think that the only thing missing for me to have actually some like in air quotes like macros or very like poor unusable macros is to move all of this into my exec function. I do think so. So if I move this upwards and I have this, right, I can do the following. So I can call this exec const char words, and this is void again. So if I do that, And here I call this one exec 0. So it's just like the cleaner stuff, right? It doesn't have any real compilation mode. It doesn't have to worry about the compilation mode. So this is like the more abstract stuff on top of that. And here I just call exec this word. This should actually support macros now. So if I have a macro, let's say I have macro 1, which basically executes another definition, it defines another word, let's say word 1, that's just does that, and then closes. What did it happen? Oh yeah, it's fine, it's fine, it's fine. Because I now have the exec at the root, yeah. It's fine. So if I call words, I now have macro 1 with this body, right? But this is never going to leave the compilation mode. Damn. Damn. Well, I could fix this very easily. Let's try. So if I execute macro 1, yeah, it's basically going to that, but it's not going to leave the compilation mode. Yeah, everything is like being appended to compilation mode. So there is one last thing we need to do to fix this, right? And support these like stupid macros. We just need to turn this into an integer, literally. We just need to turn that into an integer. And here we must say if the compilation mode is equal to 0, so there is no compilation mode currently happening, right? If it's equal to 0, we increment it, right? Well, not really. So we need to split this into the following. If we find this, we increment the compilation mode. Okay, that's okay. If we find that, we basically need to decrement the compilation mode. Like so. Then, if the compilation mode is equal to 0, so there is no word being currently compiled, let me remove that. Okay, so if the currently exactly, so if this is greater than 0, actually if it is 0, so there is no word being compiled, we execute that word. Otherwise, we need to still append whatever word we found. I think this one is going to work. So now I'm able to do the following. I can start defining a macro, which is inside of it, it contains another definition. Let's say word 1, which pushes the number 1. It closes, and it closes again. Unknown. So it tried to... So this one, the compilation mode is at 0, right? So it appends 1, 2, 1, 0. Oh yeah. So inside of here, I still need another guard, because when it reaches the ends, it's gonna be an else if. Well, yeah. So here we basically need to check if that then we can return and not do anything. That's the last thing I think, because basically when it reaches the end, this is going to be 0, but this is still going to be dead, right? Exactly, so we need to ignore that case. Let's try again once more. I'm spending more time like trying to have useless macros than actually having like useful stuff, but whatever. We have word 1, then we close twice, right? That worked. So if I call words, I have nothing. Why do I have nothing? Now something is broken. God damn. Oh yeah, of course. Because here, of course, because here I need to ignore that. If there I need to ignore this, here, well, not really. Oh, yeah, fuck. This is actually fucked up logic. I'm fucking up all this. Okay, let me, because I'm gonna clean this up later, but I understood what was the issue. So, if this is equal to 1, so we are on the first, yeah, sure, we can ignore it. This is the last try I'm going to do, other, yeah, I don't want to spend too much time on this. Okay, it's still fucked up. Okay, I'm not going to spend too much time on this. So fucking hell. So compilation modes, it increments and it decrements, right? Here, if the compilation mode is 0, so let me just test it. So if I do a 1, okay, it still works. That one still works. So it's like the compilation, the compilation thingy that's not working. Why is that? So is it never reaching that, maybe? Oh yeah, because I forgot. So defs count. Yeah. So here I can basically say if this compilation mode was set to 0 in this case, we need to do two things. We need to increment the definition count because we finished that definition, and we need to return because we don't want to execute anything else, right? Exactly. And here we can do a similar thing. So if the compilation mode is equal to 1 after we increment it the first time, we can just return, right? And we don't need this anymore. So now this should actually work. So this defines the words, 1, and then closes. Okay. If I have words, we have one word, and this word is called macro, and inside of it, the body contains a definition of another word. So if I execute macro, okay, I've just executed macro. And if I call words again, I now have two words, and this word was generated by another word, which is pretty cool, right? And if I call word 1, it just pushes a number onto the stack. So let me just clean all of these prints so it's like pretty. So if I do, I'm going to define a macro which defines like push 1, which just pushes a 1, and I do that, and now I call words, I have a macro inside of it. If I execute my macro, and if I call words, I have now another word inside my dictionary. If I call push one, I have a number in my stacks. If I call push, yeah. So that's very nice. That's very nice. It may be useful in the future. It may actually be quite useful. I was not expecting to have this kind of behavior early on in such a simple system. But yeah, so words can generate words. That's the main point. And it took me less than 2 hours to implement all of this. 217 lines of C, very sloppy C. But nonetheless, this is a functional fourth in 64-bit with signed integers. We support very like sloppy macros where words can generate words. And yeah, I mean, that's great, I guess. That's great. That's very nice for the first episode. I may, like as I said before, like I may record other videos about this topic. Maybe I'm not going to clean anything offline because I want to keep everything inside of the videos itself, inside of the series. And I want to make sure like you guys see everything. But yeah, I think it was quite nice. So thank you for watching, and I see you in the next one.